You have watched the videos, you have memorized the 4 pillars in object-oriented programming. But when you are given a real-world problem, you don't know where to start off. Unfortunately, many of the tutors are using confusing analogies and confusing terms to explain what is object-oriented programming. But that has to end with this video. I'm going to break down all the necessary knowledge and even the foundational knowledge that you must acquire before advancing to object-oriented programming. After completing this lesson, you won't be just knowing the object-oriented programming, you will be building software like a real senior engineer. In this video, I'm going to talk about the program runtime, then talk about what is an object, what is a class, then I will deeply discuss about 4 different pillars like a real human understand about object-oriented programming. I hope this lesson will be quite helpful and definitely level up your programming skills. Here we have a simple program. Can you pay a little bit of attention and try to figure out, do we have any repetition? If I may highlight, you can find out that there are 3 different blocks. These are individual purchases. You can see these 3 purchases, we have wrote the same code over and over again. It's a repetition. Repetition, it's bad. It's really bad because as humans, we have the nature to make mistakes when we are doing the same work over and over again. We want to avoid mistakes. So, what is a clever approach in this case? We can extract or we can take out the common repetitive things and put it in a one single place and use that block of code or block of statements whenever we want. In that case, we are not going to rewrite or we are not going to repeatedly writing the same statement. So that is a huge advancement compared to this previous style of writing the code. Here what we call this particular section as a method or function, or can be called as a procedure. So this common section can be called wherever we want by simply using the name and any dynamic values we want to pass into that common block of code. We actually have 2 different names for these 2 different styles. The first style, we call it as the structured programming. The second style, we call it as the procedural programming. So the whole point is we as humans, when we are writing programs, when we are writing programming code, we want to avoid repetition. So the clever approach, the solution is to utilize a procedural programming style where you can adapt the methods, procedures, or functions. It's the same thing. Those 3 words refer to the same idea. Extracting out the common logic into a one unit and then call that method wherever you want in your program. So this way we avoid repetition, we avoid making mistakes. One important thing to note about procedural programming is that the functions or methods will not be executed by its own. It waits for the exact signal to call that method. I hope now you can see the difference between the structured programming and the procedural programming. You also understand why procedural programming is better than the structured programming. You can also see by your own eyes that the left hand side has a lot of code compared to the right hand side, same code. So that means procedural programming allows you to write the same code with less number of lines. Here, before we move on from this section, remember what is procedural programming is. It is a simple programming style. It utilizes variables and procedures or methods or functions. And you can write simple programs. I hope up until this point, everything is clear to you. You understand the structured programming and the procedural programming. Perhaps you already knew this, right? Then let's move on to the next section. Now let's understand what is program runtime is. It is the time period between the start and the completion of a program. Whatever happens between that start and the end, we call it as the program runtime. Program runtime is very special, and we as software engineers and software developers pay a huge amount of attention to the program runtime, and especially about the storing the data inside that particular program. During the runtime, we have to pay special attention where we are storing and retrieving the data, because our programs are always working with data. Data can store in multiple places, files, databases, or even inside the computer memory. Just like we humans, computers also have memory. We have memory in our brain, right? Yes. Computers have a special memory card or memory component. We generally call them as memory. In this lesson, from now onwards, you have to pay special attention how we store the data inside the computer memory. Now, we as software engineers, developers, we have a special human skill that we have trained over the time, or we have mastered a special ability. Have you remembered any regular person when they got to know you are working as a software engineer or you are working in IT? They usually say, you are a smart guy, you are a clever guy, right? Why do they say so? It is this particular ability that we possess, that we have trained over the time, that the regular humans seems like we are very clever people. It is the ability that we can imagine the program runtime without running the program. It is a superhuman ability that you have to train and you have to develop and master by your own. With this simple example, let me show how you can train and start mastering this superhuman skill. Here we have a simple program. Can you pay a little bit of attention to this block of code and check what is happening here? Well, let me help you. We have a variable called temperature and we have assigned a value 25. Then we have some logic. Later again, we have modified the variable value. You should have imagined something like this inside your mind. You need to create a mind map for this variable value changes. So you need to keep track of how the variables are used and how the variables are updated or changed over the time. We call this value changing operation or value changing transition as the state of the variable. The state of the variable always associated with a given time because the state can change over the time. So state, it's another word that you have just learned. It's a very important word when we are talking about the program runtime and how the memory and the variables are changing inside the program runtime. Here is a simple challenge for you now. Can you use your superhuman skill, use your memory mind mapping, and try to check and try to see how these variables are changing over the time? If I may help you, we only have two different variables, variable X and variable Y. So you should have imagined something like this. The red color, it's the X variable, blue color, it's the Y variable. You can see the first thing that we have done was we have created the X variable with the value of 64. And then the next thing that happened is actually the Y variable got created. After that, we have actually reassigned or we have updated the X variable value. And then we do not change the variable value, or the state of the variable X did not change. You can also see we have only created the Y variable and then Y variable state did not change. I believe this is now clear to everyone. You should read more code and write more code so that over the time you will be naturally able to enhance your ability to look into the program runtime and especially the variable state changes. This will help you to debug any software program inside our mind. So you may be questioning me now, why are we learning about program runtime when our lesson is all about learning object-oriented programming? It is really important because I cannot teach you about object-oriented programming if you do not know what is program runtime and how the variable states are going to change. This is a fundamental requirement for me to teach you about the object-oriented programming. And this is why a lot of the other tutors and teachers are really neglecting this essential knowledge that you need to have to understand the object-oriented programming clearly. Now that you have understood the importance and the power of imagination when it comes to programming, let's take a look at the different styles of programming. We have few programming styles. We already discussed about the structured programming, procedural programming. Now we are going to talk about the object-oriented programming style. My dear students, the programming style can have a direct impact to the complexity of the software you are going to develop. And this is why you have to pick the correct programming style even before you select the programming language that you are going to use to develop your software application. Now that you know the structured programming and the procedural programming, we are going to learn about the object-oriented programming. Why object-oriented programming is such a huge deal? Because all the modern software applications that you know, like Amazon, Netflix, games, mobile applications, library systems, and anything that you can imagine, most of them have been developed using the object-oriented programming style. We can utilize the object-oriented programming in many of the modern programming languages we have today. So what is object-oriented programming? It is a programming style. It is also a simple imaginary concept. Once you understand this concept, you will love it. You will be able to develop your own software applications that you have actually dreamed of. First of all, I want to ask, who knows what is an object? Object, it's a material thing that can be seen or can be touched. Look around yourself right now. There are hundreds of objects that you can see by your own eyes, including this mobile phone or the computer that you're watching this exact video. It is also an object. This is the formal definition for the English word object. When we are talking about objects in programming, it's a different idea. Objects are imaginary containers. These objects can be considered as logical units. These units are combined with variables and methods. Variables and methods combine together and create an object. Objects are only available at the program runtime. So this is the reason why I taught you about the program runtime at the beginning of this lesson. Let's take a moment to understand this object concept. Here on the left hand side, I have a very simple program. We have a single variable called x, and then we have actually created two different objects, a1 and a2. Can you use your imagination, this special skill that you have to train over the time, which I considered as a superhuman skill? Can you use this and try to imagine how these objects will look like? They should look like something like this, an imaginary container. And these are two different objects. They are not related to any of the other objects or other variables. So in this case, we are imagining actually the program runtime. Now let's take a moment to understand this concept deeply. So here I have a challenge for you. Can you stay focused with me and try to find the solution for this given practical problem? Imagine you are a lead architect that has been hired by the airport flight control department. Your first task is to design a core software architecture or software system for a new flight position recording system. In this system, you have to track all the departing aircrafts from the airport and should transmit the current location, current GPS location back to the airport. That means into your new software that you are going to develop. Can you take a moment and think about how the solution will look like? As a start, let's not utilize the objects. Let's utilize the structured programming or procedural programming style. So according to our question, we first have to think about the real world story. In this story, you are the lead architect who works at the airport, and your software will run at the airport computers. But it has to communicate with the airplane that is not inside the airport, somewhere else, but it has to happen every 60 seconds. You need to check the GPS location of the aircraft. So this is our real world problem. Now we have to think about this real world problem inside a software. That means inside a program runtime. Now you have to bring your imagination and think about a program that solves the problem. First, we need to create few variables to reflect the state of the aircraft. For example, the ID and the status of the flight, whether it is flying or it is grounded, and then the latitude and the longitude, the parameters which can define the GPS location. Those four are enough for this particular problem. And then we have to think about how we get the current location. So in this case, we can imagine writing a simple method inside our program, and then we have a while loop that continuously check as long as the flight is on the flying status. Every 60 seconds, we call this get location method, which will update the GPS location of our flight. And you have successfully provided a really nice solution for this problem. You know, in an airport, there are multiple flights that are departing. So in this case, let's imagine there is another aircraft that you need to track. But we wrote a program dedicated for this one particular aircraft. How would you change your program? Now, the second aircraft is also having its own name, own status, own latitude and longitude. Now, you can't mix the variables from the first flight into the second flight. That means we cannot have common variables. We need to have a dedicated set of variables for each different flight. Since you are smart and intelligent, you decided to label the variables with a dedicated prefix. In this case, you utilize the ID of the flight. Now the each variable is dedicated for given flight. This is a clean solution. In the same way, you have already created two different methods because the methods are also different with one another. But in reality, we may not have one or two different aircrafts. We may have hundreds of different aircrafts. In this case, we may have to create thousands of different variables to keep track of these different data from multiple different aircrafts. This leads to a lot of cognitive complexity. Our brains, our human brains cannot handle this much of variables and keep track of this much of variable changes or state changes inside our head. That means we cannot think about the program runtime. We don't want to have this situation because as software engineers, we must be able to think about the program runtime. We have to be able to imagine within our head how the program runtime will looks like. So the solution is, my dear students, use of objects. Using objects will drastically reduce the cognitive complexity that we had earlier. Even though we have multiple or hundreds of different aircrafts, we can still imagine how the program runtime may looks like. According to this new code, what we actually created two different objects. This is basically we are logically grouping all the variables of a one aircraft into a logical group. This is what actually we call as an object. The most interesting thing that you may find about the objects is that the objects are independent. The variables that you put inside that object will stays there together as a group, one unit. Now, if you may pay attention to the remaining part of this code, which is the while loop and the rest of the code, we have slightly changed. That means now we cannot simply use the status variable because we have two different objects, and inside those two different objects, we have two different status variables. So now whenever we are accessing an attribute, in this case a variable inside a logical group, or in this case an object, we have to use the object name and then use a dot, and then you can access the inner variables or inner attributes of that object. In this case, you can see I have simply highlighted two examples here. We are accessing the status a variable from those two objects. So first we have to refer, or we have to mention the object name, in this case the variable name that actually holds the object, and then put a dot sign. After the dot, you can access the or you can see what are the things inside that container, in this case the variables inside that object. If someone may ask why are we using objects, you now know it allows us to easily imagine or easily group the variables and imagine the program runtime. This is the main reason we are using the objects. It's also will be helpful for us to manage the state of multiple variables as a one group or one object. Like we did in our exercise, we first thought about the real world story where you are the lead architect, you are working at the airport, and there is a flight you need to keep track of. That is the real story that we actually talked at the beginning. And then we took that story and put it into the program runtime. And then that's how we start actually thinking about how do we write the code. So when we are taking the real world problem into a program runtime, it is very easy for us to simulate the things inside that program runtime using objects. This is exactly what leads to development or creating the computer games. Computer games are not real. They are a simulated world inside a computer. How would you think creating an object inside another object? Yeah, this is an interesting aspect, right? The way we imagine connections between objects has opened many doors. It is in fact what we call as the pillars in object-oriented programming. We have namely 4 different pillars in object-oriented programming. We will cover up every single of these pillars in detail with examples of code. Few minutes ago, we discussed about the variable state and how the variable states can change over the time. Now we are talking about the object state. It is also very similar to the variable state. You can create an object with any number of variables you can imagine. According to our last exercise, we had only 4 different variables grouped into a single object. If you pay attention to this code on the right hand side, we are trying to access the status variable. Status variable can be accessed using the object name followed by the dot sign and then the status. That's the variable name. When the computer executes this highlighted line of code, the value of the status variable inside that myFlight object will be changed to landed. Now you have this question, how do you create an object? Most of the modern programming languages that supports object-oriented programming can create objects by using a class file. So if you want to create an object, you have to bring an class file to the programming language. So it will create an object according to the class file. So this is how you create a class in Java programming language. We have the special keyword called class with all lowercase English letters. Inside the class body, you write the variables what you want in every object that will be created based on this class file. You can also note that there are 3 different methods I wrote inside that class. What does it really mean? If you can remember, when I was teaching what is an object, I told you objects are made out of variables and functions or methods. In this case, I actually wrote few example methods. This means all the objects that are being created from this particular class will have their own methods that are binded to that object. Just like we binded or grouped the variables into an object, the functions or the methods will also be binded or attached to that object. In Java programming language, you have to use the new keyword. What comes with that is actually an object. So that means an object is being created at that point. Using a class file, you can create multiple objects. There is no limitation. And note that every individual object has its own state. All of these objects will have their own variables and own methods because we attach variables and methods into every single object that we create from this Java class. My dear students, if I may have to take only one thing out of this entire lesson, it will be this particular slide. It clearly demonstrates what is the difference between the class and the objects. You can have a one single class and create multiple objects. At the end of the day, what really matters is the objects because we are working with objects. Our program runtime, we do not care about the class. Class is just there waiting for the commands to create the objects. That's the only thing the class can do. So with that being all said, I want to tell you have actually nailed the object-oriented programming concept. This is the core idea that you have learned. From this point onwards in this lesson, we are going to talk about few advanced theories related to the object-oriented programming style. You know, we can create different objects and create connections between those objects. This simple idea of creating different connections between different objects allows us to discuss about 4 different pillars in object-oriented programming styles. Now let's learn about these 4 pillars in object-oriented programming. Starting off with the encapsulation. Encapsulation is a simple idea. It is all about security of your objects. In this case, you want to protect the attributes and methods inside an object. In Java programming language, you can utilize the access modifiers to control who has the access to what variables and methods. But you may be questioning, why do we want to control this? We want to make sure that the object is in the correct state at all times. We don't want to see unexpected variable changes as a surprise. Let's understand this using an example. But before that, if you would like to learn more in depth about the access modifiers in Java programming language, there is a video I have prepared for you. If you would like, you can check it out as well. Here I have a simple Java application with a simple Java main method. So this is the entry point of our application. Now I'm going to create a new Java class. Let's call this class as the student class. So student class can have multiple or any number of variables you can imagine. But for this example, let's imagine we have two different attributes, the name and the age. Now let's create an object from our student class. The idea behind encapsulation is that we want to prevent direct access. If you pay attention to line number 4 and line number 5, we are actually accessing directly the internal state of the student variable. You can see we are directly accessing the attributes or variables inside our object. So using this dot sign and then directly accessing these variables is not recommended. So let's utilize the access modifiers in Java to prevent this direct access of our internal state in the student object. Private keyword is a access modifier in Java. When you decorate any variable or method with the private, that means whatever the variable or the method is only accessible inside that particular class. In this case, the name and the age variables are now only accessible inside the student class body. So if we switch back to our main method, now you will see there are compilation errors. It says that we are trying to access the private modified attributes or variables outside the student class. But we need to access those variables outside the student class. How do we do this? The recommended practice is to utilize the controlled methods. That means we have something called getters and setters. If we switch back to our student class, what we can create, it's a getter method. Getter methods are simple public methods that expose the internal state, in this case, the private variables to the outside world. You can write the getter methods by your own. Anywhere between those curly brackets, right click and click the generate option. There you will see the getter option. Click on that and then highlight or select both the attributes and click OK. So it will generate the simple Java methods. And if you pay attention to the method names, you can see they both start with the get prefix. So this is why we call these methods as getter methods. They are doing nothing, simply exposing or returning the private decorated values to the outside world. Let's switch back to our main method and utilize those getter methods. Now line number 4 and 5 we have to comment because we cannot or we are no longer able to access the internal variables of the student object because we have decorated them with the private access modifier. So we cannot simply write s dot any variable which have decorated with the private access modifier. So we will comment it for now, and at the places where we are trying to read, we can actually utilize the getter methods instead of directly accessing those variables. Now you can see the student name is null and the student age is 0. What are these? The null and the number 0. Where they come from? In the student class, we do not have any way to assign the values for these two variables. So that means Java have actually assigned default values depending on the data type of this variable. Now we need to set the values for those two variables that we really want, not the default values. So how do we do this? Inside the student class, just like the getter methods, we have something called setter methods. If you right click and go to generate, you can click the setter option. Here also, similar to the getters, you can generate these setter methods. In this case, the set name allows you to set or pass some value which will be able to update our private variable name. Now let's switch back to our main method and try to set the values using the setter methods. Now in our main method, we will uncomment and try to set the values. Now you know the name variable is private decorated one. That means we cannot access it by simply using the dot operator. Instead, we can utilize the set name function or the method that we just created and pass the value that we want to set into that variable. Similar fashion, let's use the set age method here. Now we are really protecting the internal state of the student objects. However, we can further enhance this particular design using the constructors. If you know the values that you need to set into the internal state at the time of object creation, you can utilize a custom constructor. The idea is instead of using the setter individually, you can simply pass the variable values directly into the constructor. So this is a constructor. This is not a method. Constructor is a special part in any Java class. How do you differentiate a constructor with an existing Java method? You can quickly spot any constructors by looking for the same name as the class name. If you have the same name just like the class name, that is a constructor. And also note that there is no return type just like the methods. For constructors, we are not writing any return type. We can further enhance our student class to have more controlled access to the outside world. In this case, let's imagine you are assigning or you are setting the age with an invalid value. For example, -15. You can see the value has changed because we use the set age method with the -15. But you know, this is actually an invalid value. So in the setter, we can actually have a restriction. Now inside our setter for the age variable, we are having a controlled access. We are checking if the value that we are getting as the input is less than or equal to 0. If it is so, it is an error. Otherwise, we will go ahead and assign that value. So now let's go ahead and try to run our main method again. Now you can see we are getting the error as well as we are protecting our initial value, initial state of our student object. Inheritance is a very natural and a beautiful idea that we can see in our day-to-day lives. In object-oriented programming, inheritance allows us to represent these hierarchical relationships among our objects inside our programs. In Java programming language, you can utilize the extends keyword to denote parent to the child class relationship. We usually call inheritance builds up a is a relationship. In this quick exercise, we are going to understand how to represent inheritance among two different classes. That means one has to be a parent, the other will be the child class. First, I will go ahead and create a simple Java class called user. Now in my main method, I will create an object from the user class. You can see here we have the name as the null because we actually did not set the name for our object of the user. So let's utilize the user.username and then assign the expected username. Now, if we rerun the program, you can see the username is correctly printed to the console. Few minutes ago, we learned about encapsulation. So let's try to utilize encapsulation concept and try to protect the username variable inside that user class. We can go to username variable and then decorate it with the private access modifier. Once you do that, once you mark the variable, it's the private variable, that means it will be only available to access or utilize inside the user class body. If we head back to our main method, now you will see there is a compilation error saying username has private access in the user class. But now the question is, how do you set the value for this username variable? You learn there are two options. The first option is to go for a setter method. The second option is to utilize the custom constructor. I will go for the second option because I know the exact value at the time of the user object creation. So I will create a custom constructor inside our user class. The main highlight of this particular exercise is to showcase how you can implement parent-child relationship. So let's imagine the user class as the parent class. Then we can create another class and connect them or link them using the parent-child relationship. In that case, user class will be the parent class and the new class that we are going to create will be the child class. I will call the child class as the admin user. In Java programming language, you can connect or you can mark the inheritance using the extends keyword. Extends is a reserved keyword in Java programming language where you can mention the parent class for your given class. In our admin user class, we have a couple of problems. The first problem is, if you remember, inside our user class, we have created a custom constructor. Through the custom constructor, we are passing our custom value for our username variable. In Java programming language, any class you create, there will be a default constructor, whether you write it or not. But if you write a custom constructor, that default constructor will no longer be there. In that case, the child classes will have problem finding the default constructor in the parent class. In this case, what happened was inside the admin user class, now we try to look for the default constructor in the parent user class. But in the parent class, in this case, the user class does not have a default constructor. Therefore, it complains or it asks to implement a custom constructor inside the admin user class, which will be able to call the custom constructor in the parent class. So let's right click and create a custom constructor for our admin user class as well. Let me show that chaining of constructors by simply putting a print statement inside our constructors. Before we run the main program, there is another problem that we need to fix inside our admin user class. Admin user class is a direct child class of the user class. The username variable is only accessible within the user class. If you remember, we decorated the username variable with the private access modifier. Private access modifier, it's the most secure access modifier which only allows the variables or methods only inside that particular class. In this case, the username variable is hidden even from the direct children. So let's remove this access modifier and decorate with the protected access modifier. Protected access modifier has three different levels. Inside the same class, inside the same package and all the child classes. Now, if we switch back to our child class, you can see the error has disappeared. Now the variable is accessible to all the children classes of the user class. Now let's head back to our main program and then create an object from the admin user and see how it works in the runtime. In the terminal, you can see the print statements that I have added for individual constructor. The first print statement is coming from the user object creation. At the time of creating the user object, first it called the construct of the user class. Now you can see even the time when we are creating the admin user object, it got called the parent or the user constructor through the constructor chaining. Let me go ahead and call the final method of our admin user class, which is the delete data. You can see this alert is coming from the delete data method, and also which is notable that the variable which is defined in the parent class is accessible within the child class. So with this simple exercise, we understood how to represent parent-child relationship. We call this as the inheritance. In Java programming language, you can utilize the extends keyword and then mention the parent class. Most of the times, students may find it difficult to understand what is abstraction is. Abstraction is a very simple idea. The idea is all about avoid code duplication. When we have multiple classes, sometimes we may find some of the properties or methods can be repeated. In that case, we can utilize the abstraction. Abstraction is taking out the repeated lines or repeated variables and methods from multiple classes and then put them into one central location. That central location can be an abstract class or an interface. But now you may be confused. How does it differ from the inheritance and the abstraction? In inheritance, we are actually representing parent-child relationship. In inheritance, the parent class is also representing an real object, so that the parent class itself, it's an independent class that can produce multiple objects. But in abstraction, the whole point of abstraction is different. We are not demonstrating a parent-child relationship. We were simply extracting out the common parts of your code and put them in a central location. That central location does not represent an actual object. So this is why in Java programming language, you cannot create objects from abstract classes and interfaces. Because abstract classes and interfaces are meant for extracting out the repeated lines of code and then put them into a central location. That central location do not have the complete knowledge to represent an real object. So this is the real differentiation between the inheritance and the abstraction. After you have extracted out the multiple repeated sections into a common place, that common place can be seen as the prime example for the abstraction. That place do not showcase the whole picture. You need to go into the implemented classes of that particular common section. Abstraction is really powerful. When you are writing complex applications, you may find different places that are repeatedly doing the same thing. So you may need to utilize the abstract classes or interfaces when you are writing complex software applications. So it is important that you truly understand what is abstraction and how you can implement or how you can utilize when you are writing software applications. In this section, we are going to explore how you can showcase abstraction when you are writing Java code. In Java programming language, you can actually showcase abstraction with two different types of constructs. That is the abstract class, or you can use an interface. So first I will showcase a simple example how you can use an abstract class and implement and demonstrate what is abstraction. And once I complete that, I will take a separate exercise and showcase how you can demonstrate abstraction using an interface. First, I'm going to create a simple Java class. I'm going to call it as the soup class. So my idea is I want to showcase code repetition in two different classes and then trying to extract them into a common location. In this case, the common location will be the abstract class. You can see we have simply wrote two different public methods. Now let's head back to our main method and try to create an object of our soup class. Keeping that aside, I'm going to create another different class called salad. Now you can see when you run the program, the main method, you will see the first two statements are actually coming from the soup object that we created out of the soup class. The second two statements are coming from the salad object from the salad class. Now you can see between the salad class and the soup class, we have the same method wrote inside those two different classes. And those two different classes does not have a common parent class. In this case, we have no inheritance at all. But we have actually wrote the same method in those two different classes. That is code duplication or code repetition. We want to avoid writing the same thing. In this case, we can use an abstract class. I'm going to call this abstract class as the meal. First, you simply create a regular Java class, and then before the class keyword, you can label or you can decorate this class using the abstract keyword. Inside our abstract class, our idea is to avoid code repetition in our salad class and the soup class. And we already identified that the prepare method in both of those different classes are exactly the same. So we can take out that exact method from the any of the class because they are identical and then place it in our abstract class. Now you can see inside the soup class and the salad class, there is no prepare method. You can see if you pay attention to the main method, there is no prepare method from the soup object and the salad object. So it will not compile. Actually, you cannot now run the main program. But we actually need to have it. It was there before. So we cannot now take out of it. So in this case, you can simply extend these two different classes from the meal class. Now, once you do that, through the inheritance properties, the meal class automatically become a parent class. But in this case, it is not a regular class, it's an abstract class. So this method will be written in a one location and it will be distributed across all the child classes of this meal class. In this case, the child classes are the salad class and the soup class. Now you can see the main method have no problem. I can simply run this main method as well. Here you can see there are no problems with the original state of our program. Now let's imagine somebody later decided to add another type of food. In this case, let's imagine they want to add a fried rice. So what they do is usually they simply create a dedicated class for this. So our fried rice class can also extend from the meal class, which is our abstract class. Once you do that, if you go to our main method, let me remove this because we understood the idea. If we create an object from our fried rice class, now we have the prepare method. But do we have the cook method? No. Why? Because inside our fried rice object that we create from this class do not have a cook method. But we assumed that cook method will be there in individual class, in this case individual child class of this abstract class. But in this case, the person who wrote the fried rice class later did not know that there must be an cook method. It could have been avoided if we have actually properly wrote the meal class. Inside our meal class, since it is an abstract class, we can write something like this. So this is our abstract method signature. You can see this method signature has this special decorator, which is the abstract keyword. And what you have to pay attention, there is no method body. If there is a method body, we denote it with the curly brackets. But we don't do that for the abstract methods. We only provide the signature. The method body, the implementation, must come from a child class of this meal class. Now let's head back to our main method and try to run our main program. You can see there is a compilation error. It is coming from the fried rice class we created, which is a child class of the meal class. The error says there is no implementation for the abstract method of cook, which is correct. You can simply hover over this error and then click on this implement methods. In that case, it will showcase this pop-up menu and click OK. So what is this? This is the abstract method we define in our meal abstract class. You can see this is the exact signature, except that now the abstract has been taken out because we are providing an implementation. So in this case, I can write my method body. Now you know, if you have multiple methods or any block of code that has been repeated across multiple Java classes, you can utilize the abstraction with the help of a abstract class. But there is a huge limitation on this entire approach that we understood. The limitation is actually coming from the Java language, that you cannot have more than one Java class after the extends keyword. In Java programming language, you can only extend from a single Java class. So in this case, what it really means is you cannot have multiple Java classes to be written in this point. After the extends keyword, it must be always a single Java class. The solution is to utilize an interface. That is what the second part of this exercise that we are going to discover. Before we move on from this exercise, I want to remember that you cannot create objects from any abstract class. For example, the meal class that we created, we decorated with the abstract keyword. That means you cannot create an object from this Java class because this class does not have the complete knowledge. You can see there is a one method that we marked with the abstract keyword doesn't have a method body. So that means Java cannot simply create an object. Let's head back to our main method. I want to show you, you cannot create objects from any abstract Java class. You can see this will not compile because the meal class itself independently does not have the complete knowledge to construct an object. Java will not allow you to create an object from any abstract Java class. So in this part, we are going to explore what are interfaces in Java. When I say interfaces, I didn't mean any layouts and buttons and different scroll buttons and things like that. Interface in Java programming language, it's a dedicated construct. It is very similar to a class file, but instead of class, we use interface. Interfaces are basically contracts. They only mention the method signatures. They don't care about the method implementations. Method implementations must come from the classes that implements that particular interface. So in this example, we are going to create two different Java classes, and then later we are going to create a contract using an Java interface. Now, when you pay attention to these two different Java classes, you can see the send message has been implemented or written in those two different Java classes. However, the method body is different. The implementation is different. The idea about interface is basically if we want to make sure all the child classes are implementing set of methods, but we don't care about the method body, but there must be those particular methods, then we should adapt an interface. Interface, just like I told you, it is basically a contract. So in this scenario, we can adopt a contract for this human class and the robot class, because we can say the contract is you must implement the send message method. Now, inside any interface in Java, you only write the abstract methods and you don't provide the method implementation. The public and the abstract keywords for any of the methods definitions that you write are actually implicit. That means you don't have to write it. In any Java interface, Java knows all the method signatures are by default, they are public and abstract. So we can remove this unnecessary decorators. You can also keep it, but that is redundant because Java knows. And we can only keep the return type and rest of the method signature. Now, if we hit back to our human class, we can make sure that we implement the communicator interface. Once you do that, you can see the IDE highlights that this method is simply implementing the interface definition or the contract that we signed. So we are saying the human class is implementing an communicator interface. Let's do the same adjustment for our robot class. Now you understand the interface is more strict when it comes to the implementation rules. The beauty about using interfaces is that you can actually utilize multiple interfaces with the comma separation. For example, let's say if we want to implement another interface, this is an interface in the Java JDK, you can actually implement multiple interfaces as much as you want. There is no restriction like in the abstract classes. So if we summarize what is an interface, interface is basically a contract. If you want to define set of methods in a one single place as an abstraction, you can utilize an interface. In practice, we utilize more interfaces compared to the abstract classes because, like I was highlighting in the human class, you can mention multiple interfaces after the implements keyword. Implements is a reserved keyword in Java that is denoting which interfaces we are implementing inside the Java class. In this case, the human class is implementing communicator and also the serializable interfaces. Good job, my dear students. You came to the final pillar in object-oriented programming. It is what we call as the polymorphism. In fact, there is no proper ordering of these four different pillars. Different teachers may pick different topics or different pillars to start with, but I personally find there is actually a natural order. The order that increasing difficulty and relevancy to the next topic. And this is why I kept the polymorphism as the last pillar to teach you. It is actually a byproduct of inheritance or abstraction. Since now you know what is inheritance and what is abstraction, it is quite easy for me to explain what is polymorphism. To demonstrate polymorphism, you don't have to do anything. You only have to implement either inheritance or abstraction. And as a result, you will see inside your code, there is the polymorphism automatically appearing inside your code. So what is polymorphism? Let me take a simple example. Let's imagine you are very good at acting. So at school, you are volunteering to conduct a drama at your school. In this situation, there are not much other students volunteered to act in this particular drama. Unfortunately, you have to act two different characters in this play. Let's imagine one character is a student and the other character is a principal. So when you are acting or when you are performing this drama, you are actually taking different profiles, right? Profile as a student, profile as a principal. But does that mean underneath yourself, you actually change? No, it's the same person, but you are behaving or showcasing different set of characteristics in a given situation. So this is the same idea when we talk about the objects inside a program runtime. Sometimes some objects have lot of upper layers so that underneath object that we create at runtime can act as different profiles. Maybe you still don't understand how it can happen at runtime. I am pretty sure this particular next exercise we are going to do will clear up all the doubts you have about polymorphism. In this exercise, I'm going to first demonstrate the inheritance setup and then what is method overriding. First, I'm going to create a class called device. Now, inside this device, there is only a simple method called show status. Keeping this aside, I'm going to create another class. In this case, I'm going to call it as the smartphone. Now, smartphone is a device. So we have the is a relationship. In this case, this is a child class of the device class that we just created. So we can use the extends keyword and mention the parent class here. Now, once you do that, you have the ability or you have the possibility of overriding a method. What does it really mean? Overriding a method means a method that is defined or written inside a parent class, in this case, the show status method, can be overridden inside the child classes. So we have only a one single child class. I am going to override this show status method inside my smartphone class. Now inside the method body, I need to provide a different implementation. That's the whole idea. Otherwise, I could have kept it only inside the device class and simply utilize it, because through the inheritance, I will be anyway able to have the access to the parent class method. I will change this simple print statement to be different than the what we have on the device class. This is something we already learned, but method overriding is something that we didn't cover there. You now know it is possible that you can provide a different implementation under your child classes. That is what we call as the method overriding. You have to remember the method overriding, you cannot change the method signature. It must be the same exact method signature like in the parent class. Now let's go ahead and create a new interface called rechargeable. You know, inside an interface, you are only allowed to write method signatures, no method bodies. So I'm going to simply write a method signature called recharge. Now I'm going to head back to my smartphone class and going to sign a contract of rechargeable with the smartphone class. So how you do this in Java, you can use the implements keyword and mention the contract, in this case, the interface that you want to adhere or that you want to sign the contract with. Now you must provide the method implementations for all the method signatures that are defined in the rechargeable interface. In this case, we only have a single method called recharge. We only have to provide the implementation for this single method. Now you can see our smartphone class is actually extending from the device class, and at the same time we are implementing the rechargeable interface. Now inside our main.java file, I'm going to create a separate method called run system check. As a parameter for this, I'm going to accept a device type. Now inside this method body, all I know that I'm going to receive a device object. I don't know specific details, whether it can be a device or it can be a smartphone or it can be a new type of child class. I don't know. But all I know for sure that it is a device type object. Now let's go ahead and create a smartphone object, then see how it affects when we run this particular run system check method that we just wrote here. Now let's run the program and observe the output. Here something interesting is happening. So let me break it down to you. So let me look into our run system check method. In this method, we are expecting any device type object. So it doesn't matter it is really a device type object or child class of the device type object. In fact, at runtime in the main method, we have created a smartphone object, not the device object. So this is the child class object that we created, and then we passed into the this particular method. So at runtime, when we are calling this particular method, when Java calls the show status on the device that we received, Java actually executes the overridden method version. If you can remember, inside the device method also, there is a show status method. But this is not what we are seeing here. We are seeing the overridden version of this particular method. So you have to remember, when we are calling a method from a reference at runtime, what it matters is the underneath object. So when we have a method that has been overridden version, Java executes the overridden version of this method. So show status method have been overridden inside the smartphone, and since we are actually passing a smartphone device here, we are executing the method from the smartphone class. I hope that clears out. It is a very tricky situation for most of the new beginner students, that they find it difficult to understand how this overridden method was being called. So I hope my explanation is clear. When you have, even though a parent type reference at runtime, in Java sees an overridden version, it executes that. Now, if we may rerun this method, not with the smartphone object, let's create a device on the spot. That can be done using the new keyword and followed by the device calling the default constructor of the device class. Now, if we may run the program again, now you will see the implementation is actually picking from the device, because you can see we have just created a plain fresh device object. In this case, we don't have the overridden versions for the show status. Instead, it just picked the show status method from the device class itself. Okay, now let me remove this for a while, and then now keeping this aside, I'm going to create another new method in my main.java file. This time I'm going to call it as the charging batteries. As the input for this method, I'm going to accept a rechargeable instance. Now, just like our previous method, in this method, what we are accepting, it's a rechargeable instance. We don't know the exact type of the object. All what we know it for sure, it has actually fulfilled all the requirements of the rechargeable interface. That means that object have actually implemented all the abstract methods that are defined inside the rechargeable interface. Now, if you remember, the smartphone class in fact implemented the rechargeable interface. Therefore, we can actually use the smartphone object and call the charging batteries method as well, because the smartphone object can represent an rechargeable instance. So let's run the program again and observe the output. So with this exercise, we learn the same smartphone object was able to act as a device type inside the run system check method, and inside the charging batteries method, the same smartphone was able to represent or act as the rechargeable instance. So this is the power of polymorphism. The same object can appear at different places with different profiles. In Java programming language, you can create .java files. Inside those .java files, we can have a class or maybe an abstract class, or it can be an interface. When you open any Java class, most of the time you may see a class body. We can utilize a class to create any number of objects. If you have an abstract class, you are not allowed to create an object from that class, because abstract classes do not have the complete knowledge. Without having the complete knowledge, you cannot construct, or Java cannot create an object from that class. Compared to the abstract classes, interfaces have no information at all about the implementation details. Interface is purely a contract. It only specifies what has to be there, but not how it has to be there. So this means you cannot create objects from an interface. If you are interested about learning Java programming in depth, just check out this course, which is available on my YouTube channel for free. And there you have it. Congratulations! You have mastered object-oriented programming. If you like how we broke things down here today, you can check out my YouTube channel. You will find interesting tutorials there. I am here to help you grow. If you have any specific topics that you want me to tackle next, please let me know in the comments. Thanks for watching all the way through, and I'll see you in the next one.